Determine whether the line 0, 5, 1 plus t, 2, 1, negative 4 is parallel to or intersects with a line that passes through the points 2, 3, 1 and 4, 1, 1. So we're given 2 points for this other line. We'll deal with the equation of the first line in a moment. But we don't even have an equation for the next line. We don't have an expression for it. So we're given 2 points. We could just put it in 2-point form if we wanted to. But, well, you can't do a whole lot with 2-point form. We could, however, instead use our 2 points to get a direction vector. Right? Put those 2 points, they're on the line, and then the vector going between them will lie on the line, and it'll be a direction vector. Now, why would we care about this direction vector? Well, to tell if two lines are parallel, the direction vectors need to be scalar multiples. So we can get a direction vector for this line. 2, negative 2, 0. So that's a direction vector. Now, what about the other line, the first line we were given? It's got a direction vector of 2, 1, negative 4. Okay. So is 2, 1, negative 4 a scalar multiple of 2, negative 2, 0? Can we find a value of c that makes this work? Okay. Well, 2 would need to be the same as 2c. 1 would need to be the same as negative 2c. And negative 4 would have to have the same value as 0. We don't even need to work out that c here is 1 or that c is negative 1 and that makes it fail. The fact that negative 4 would have to be 0 tells me there's no way that this vector could be a scalar multiple of this direction vector. So the lines are definitely not parallel. Okay. So then one would assume that these lines are intersecting. Okay. So we could check, do they have an intersection point? Well, let's find that out. So we could take the 2-point form we got here, and expand it out, 4, 1, 1, 1, 2t, 3t, t, 4 minus 4t, 1 minus 1t, and then 1 minus 1t. We get 4 minus 2t, 1 plus 2t, and just 1. So the 2-point form line, or the line that we were given 2 points for, we can get a parametric form for it. Okay, and then the other line we were given, oh, sorry, that line used a t. I should probably switch these to s's. Because otherwise, plugging things in is going to be a little nasty, because we'll have the same letter meaning different things, and that's not right. We'll change those all to s's. So our second line is x equals 4 minus 2s, y equals 1 plus 2s, and z equals 1. And the first line, we were given point parallel form, but it doesn't take too much effort to work out parametric form. So 0, 5, 1. And then the coefficients for t are the components here. So 2t's, 1t's, and minus 4t's. Okay. Now, if these two lines are have a point of intersection, then we should be able to set the x values equal, set the y values equal, and set the z values equal. Okay. Find values for s and t so that when I take the value of t that I find, the value of s that I find, and plug them back in, I will get the same point on both lines. So we just sort of need to solve this set of equations here. So let's look at the third equation. 1 minus 4t is 1. Let's subtract 1 from both sides. Negative 4t is 0. So t should be 0. Okay. Now that I know t should be 0, I could take that and maybe plug it into the first equation. So 2 times 0 is 4 minus 2s. So 0 is 4 minus 2s. Negative 4 is negative 2s, so s should be 2. Now if I take this value for t and s and I plug them back into their respective lines, do I get the same values for x, y, and z? X, y, z, so 2t, t is 0. 1 minus 4t becomes 1 minus 4, 0. And 5 plus 0. So the first line, the point we think is the point of intersection is, 0, 5, 1. Is that point also on the other line? Well, if it is, we should get it by plugging in s equals 2. So 4 minus 2 times 2, and I think it was a constant of 1, and then 1 plus 2 times 2. So 4 minus 4 is 0, 1 plus 4 is 5, and 1. So yes, 0, 5, 1 is on both lines. So they intersect. Okay? They are not parallel. We already worked that out. The direction vectors we found are not scalar multiples, but we were able to show that they have a point in common. So these lines intersect.